Hello everyone. We are starting a free open lecture on our Discord. All our lectures are held weekly without breaks. If you, the viewer, want to ask questions and get detailed and comprehensive answers in an online format, join our lectures. You can find the link to our Discord in our Telegram channel. To find out the lecture times, join our Telegram channel. Now all that's left is to join the squad. Insert these objects there and the task is solved. Very simple. Well, let's just take a look at the code I've actually written here. This is a classic segment tree with lazy propagation. You have his code. Actually, here I initialize this n26, which is the size of the alphabet. And here I have, well, this is actually exactly the value, my value. As I already mentioned, I basically use a vector, meaning this is the value that will be stored in my tree. And here I have an array of screws of size n, which means an alphabet essentially, basically in essence, in other words. So by default, it is always filled with zeros. By the way, this will be my neutral element. If I add something to the zero vector, I will get what I added to it. This is another constructor. I needed it in order to set the value at the specific position, specifically for apply, this thing right over here. So I set the value 1 to the lazy position. Then I use the plus operator as a function on the tree, which means adding two vectors. This is exactly what I need here at the beginning. This is my advantage, kind of on the complexity. The vector adds up, I think everyone understands. And here I immediately included a method to check if my vector can be a palindrome. How do I verify this? I count the number of odd elements, and if this number is greater than 1, then it cannot be. If it is less than or equal to 1, then it can be. So I essentially chose -1 as the neutral element for the lazy value because everything from 0 to 20 will be used. So why not basically take -1, essentially? Here is my lazy apply, which basically means when I apply the lazy value to the value on the tree. And also L and R are passed here. And so if I have, well, basically I could have done without them here because here I will have a difference of 1 if R equals L. I am in a leaf. Well, if I have this neutral value, then I just simply return what was there. Otherwise, I basically return that node and call this constructor. So, I set this specific difference, the exact number of elements in the segment, precisely to the lazy position. And the composition of lazy, it looks like this. I have two lazy values. If I have a new neutral value, then I return the old one. Otherwise, I return the new one. It's kind of like assignment.
Want to become a great programmer? Subscribe to our Telegram channel.
That's it. I basically build the tree, essentially from the string. I convert each and every individual character of the string into a corresponding vector, where a 1 is placed precisely at the index position of that particular character. My vector consists of all zeros with 1 at a certain position. I set this up to all positions in the tree by the indices of this string, respectively. Then, I simply process these queries, one by one. First, I request the characters that are in the segment from LDR, which is a vector representation. Here is that node in short. Then, if it cannot be a palindrome, we stop processing this query and ignore it. Well, otherwise, we end up going through each character in this string. By default, they are in a sorted order, we can say, because I have the character A at the 0 index, and the character Z will be at the last index. Thus, accordingly, I definitely guarantee that my string will be lexicographically minimal. And what do I take next? So, I have all the characters here resulting in data ita. Then I should place half of it at the beginning and half of it at the end. Accordingly, here is how much I will place at the beginning and how much at the end. So if my count here is greater than 0, meaning there is at least a 2 or something greater in the data, then I use lazy. application. That is, I set the value lazily on which segment. From the left edge to L plus count minus 1, well, here I have L, and if I have, let's say for A, yes, my count for A is 3, so here it's 3 and here it's 3. Then here I am on the exact segment from L to L plus count plus 3 and minus 1. Exactly. On this segment, I set A, and also here is the second call from R count plus 1 to R, which corresponds to this segment, where I also set the characters. Additionally, I need to add the count. By the way, I have 3 attempts, and all 3 attempts failed on the 7th test because I didn't write this thing. I thought there was some mistake in my tree, but I completely forgot about this. We shifted it, so we kind of already have the boundaries here, so that I could use the same thing. Yes, my B is already like this. I have L located here, but L plus count will be this, and R will also be located here. R minus count will be this. So, and also at the end, well, if I have an odd number of characters, then this one remaining character will be exactly in the middle. It's L plus R divided by 2, and I just place my value there. A 2 or not a 2, huh? And I place the character, and since I am guaranteed that this character will only appear once, which has an odd occurrence, then accordingly this character will work for me so that it appears once, and that's it. This is query processing. And in the end, all I need to do is go through all the characters n. Oh, by the way, yes, there's also an additional complexity of plus n at the very end because I need to calculate. And here plus n, well, at the very beginning, by the way, also n because I need to build the tree. Even on C, n on C, I go through each character and just take in, well, since the query is from this to that, it means I will descend into the leaf 100%, and I just need to understand what value the unit has in this leaf. Here is the first thing that has a unit, which means this character, it is there for me. I input simply through the addition of characters. That's all for today. Thank you, everyone.
Want to become a great programmer? Subscribe to our Telegram channel.